Divide complex numbers. Let's jump in. What is a complex conjugate? Well, to divide complex numbers, we have to have a complex conjugate. So remember that a complex number in standard form is a plus bi. The complex conjugate is a minus bi. So notice essentially the same standard form there, except instead of a positive, we have a negative. We're going to flip that sign of the complex term in order to get the conjugate. When these two numbers are multiplied together, a real number is the result. When we have a plus bi, just stay with me here. If we distribute that, we get a squared, and then a times negative bi is abi, negative abi. Positive bi times positive a is a positive abi, and then we get bi squared. Well, the middle term, negative abi plus abi is 0, which will always be the case. And remember that I squared is always negative 1. So that last term becomes b squared times negative b squared times negative 1, which is a positive b squared. So you'll notice when you multiply by the complex conjugate, the entire complex part of that number is gone. And that's kind of the goal. So to divide complex numbers, the basic idea of this is we can never have a complex number in the denominator of a fraction. So dividing is essentially a fraction, right? The fraction bar is a division sign. And therefore, the goal is to remove the complex part from the denominator. We do that by multiplying both the numerator and the denominator by the complex conjugate. So if we have the problem 2 plus I divided by 3 minus 2I, again, in order to divide this, the denominator must be free of imaginary pieces. So our goal here is to change that 3 minus 2I into a real number. So we're going to identify the complex conjugate, which we know to be 3 plus 2I. Because if we have 3 minus 2I, all we're going to do is flip that sign of the complex piece. So now we have to multiply the top and the bottom. Remember, math is about equality. So we're going to multiply both pieces by the complex conjugate. So I'm going to have 2 plus I times 3 plus 2I. And then in the denominator, 3 minus 2I times 3 plus 2I. Now I'm going to write all of this out, the distributive property. So in the numerator, we take the 2 and we distribute it to both the 3 and the 2i. Then we take the I term and distribute to the 3 and the 2i. In the denominator, same thing. Distribute the 3, distribute the negative 2i. So you can see all of the pieces there. Now let's simplify. So in the numerator, I have 6 plus 4i plus 3i plus 2i squared. In the denominator, 9 plus 6i minus 6i minus 4i squared. Now this is where we want to simplify. In the numerator, 4i plus 3i gives us the 7i. And remember, I squared is equal to negative 1. So 2i squared is the same as 2 times negative 1, which gives us the negative 2. So in the numerator, I end up with the real pieces. 6 minus 2 gives us 4. And then we still have the imaginary piece of plus 7i. In the denominator, the 6 i's in the middle cancel out. And remember that negative 4i squared, well, that's the same as negative 4 times negative 1, which is a positive 4. So 9 plus 4 gives us 13. So our final answer to this, when we divide 2 plus I divided by 3 minus 2i, we end up with 4 plus 7i over 13. Again, the goal of dividing complex numbers is to get the complex piece out of the denominator. Let's try another one. 6 minus 5i divided by 2 plus 3i. Always starts with the conjugate. Well, 2 plus 3i, the complex conjugate there is going to be 2 minus 3i. So we're going to multiply both the numerator and the denominator by that conjugate. And then we're going to distribute. So 6 times 2 is 12. 6 times negative 3i is negative 18i. Negative 5i times 2 is negative 10i. And negative 5i times negative 3i is 15i squared. Denominator, we end up with 4 minus 6i plus 6i minus 9i squared. Again, remember that I squared is going to be a negative 1. So when we simplify, we end up in the numerator with 12 minus 28i, and then that 15i squared becomes negative 15. Simplifying the numerator, we end up with negative 3, because 12 minus 15 gives us that negative 3, minus 28i. And in the denominator, our 6 i's cancel out, and then that negative 9i squared becomes a positive 9, and again, our denominator is 13. So when you divide 6 minus 5i divided by 2 plus 3i, we end up with negative 3 minus 28i all over 13.